Greetings everyone, this is Zunayed here. Data cleaning is a very important part in data science. When you are working with data, a lot of complicated data, complex data, like thousands and millions of rows, and then it is very mandatory to make the data workful or workable for you. So that's where the cleaning comes. There are a lot of unnecessary data, or there might be some data that you need to modify for yourself so that you can put it into your machine learning model, so for it to learn. So data cleaning is a very important part of data science or data analysis. So that's where a new thing, that's a software called OpenRefine, comes in. OpenRefine makes this process a lot easier, a lot visualistic, so interactive also. OpenRefine, the thing that you can do with OpenRefine can be done using cores also. You can use pandas, but for the time being I'm going to show you the process of OpenRefine, because for those who are not into coding, those who would like to do things more easily and more efficiently, OpenRefine is the right choice for you. So to install OpenRefine, you are supposed to go to this website, and you will find a lot of types of operating system. Based on your operating system, you can download OpenRefine. Here at the time of recording, the latest version of OpenRefine is 3.6.2. so I have it already installed and opened. So when you open OpenRefine, you will find this window opened in your browser. So it means that this OpenRefine software is basically a web-based software. Here you can see, you will be able to see this computer, web addresses, clipboard, database. You have to basically import data or data set from your computer. You can also import it using URLs, or you can also copy and paste it from your clipboard. However, for the time being, I'm going to import it from my own computer. So I'm going to go to my desktop, then study semester 9, this course here, and this folder. Here I have this data here. This is a CSV file. I'll click open and click next. It will take some time to open, and it is going to show me a preview of this file. So I can see it's a very long data. So here this is already selected, that is a CSV file, so it has detected. And to make this data set trimmed or trailing white space, then you have to click on here. So I'm going to click here, and it will bring some changes. However, after that, I have to give my project name. I can change my project name, you may not want to, but let's keep it as it is. Then click on create project. Once it takes some time, it will show you that how much of your memory or RAM it is consuming. Once it's done, then it's going to show me the first preview or the data. As you can see that there is show 5, 10, 25. So these are basically the row numbers that you want it to show in your preview. So if I click on 5, it's only going to show me 5 rows. If I click on 10, it will show me 10 rows. If I click on 100, it will show me 1000 rows. So but there are 35,000 or more than 35,000 rows here. So if we choose all of it or the higher rows, then it's going to process a little, it's going to take a lot more time as much as you increase the rows. So it's always better to use a less number of rows to work, so that your software doesn't take too much time on just visualizing your data. Okay, so there are a lot of columns here. We can see that survey ID, record ID, this probably month, this year, then this period, then plot ID, plot, node stack, scientific name. I can see this one is interesting. There is locality, and there is JSON, and there's a lot of other columns of this in this data set. So the first thing that we would like to see is showing the facets. You see that there is this scientific name ID. This is basically a text column where every data is text, but you can see that there are a lot of differences. There might be some differences because this is a scientific name, and scientific names are quite difficult to type even. So let's see. To see the text facet, you have to click on here, then facet and text facet. So here it goes. Here is showing me that here is Amoderma severanum, which happens 2 times, then Harisi 1 time, and then again Harisi. But you see that there are spelling differences. For a very simple amount of change, it has only some changes. That it happened 1 time, it happened 1 time, but this one happened more, a lot more. This is 435 times. So it means that probably out of these 3, the second one is a correct one. Other 2 have a little errors in their spellings. You can see that there are same cases everywhere. Here is also, then probably here too. So these things can needs to be changed. Or if you want to see here year facet, click on year, then face, then timeline facet, then okay, it doesn't show on time. Alright, probably this one not. Without face, numerical facet. Okay, so in this facet the data is not in numeric. So to change, make it numeric, we can go to edit cell, common transform, and then to numbers. So every item here has been converted into numbers. So as you can see, these are green, right? So if I click on here, then facet and numeric facet, you can see that the time from 1977 to 2003. So to make them time, we can do a cell, common transform, and to date, then it will show. Okay, it's taking some time. Okay, now it shows the time format. So this is the common by default format of the time. Here it is also green, and this is the default format of showing time. So if I want to show the timeline facet now, it's going to show me the timeline facet here. So it makes more sense, I guess. Okay, so this was about showing your year, timeline facet, and scientific name for text facet. So I hope it makes sense here. These faces are basically for visualizing the data or a particular data in your data set. Now, earlier I discussed about the scientific name ambiguity. Here these things needs to be solved if we want to work on it. So what we need to do here is that we have to click on the cluster. So if I click on cluster, they can say that there is a method and there is a keying function. We can choose anyone, nearest neighbor or key, whichever we want. But when chosen nearest neighbor, you can see that this Amphispisa billenata, I'm not sure how to pronounce it. Anyway, but billenata and selenata, these two are not same, but this algorithm or this method is showing that these are same. So this method probably is not performing too good for solving this problem. You can choose key collision and fingerprint showing. So let's say we go for metaphones. So if you cluster using this 2 combination, then we can see that it's saying that Amphisia billenata and these are almost same. So which makes sense. Again, Amphosma Harisi. Okay, fine. These are according to this method and this keying function, these can be merged. As you can see here, the average choice in cluster, those are very low here. So to merge them, you have to click on this icon here, select them, and then click on merge selected and recluster. So what will it do is it will consider them as one and merge them. Now let's close, and this problem has been solved, I guess. So yes, these are now, if you look at the scientific name cluster facet here, it makes more sense now. All right, now that we need to we have discussed about clustering and solving the problems of ambiguity, disambiguity, where the names look similar but little scientific in the spelling mistakes in the scientific names. Now let's see how you can split the data. To split the data, there is a scientific names, a lot of scientific names. So if we click here and then go to edit columns and then go to split into several columns, here is saying that the separators, we can choose that how we want to separate the column. Okay, so here it is comma by default, so I want it to be space, nothing here, space, and then we have to click on that remove this column as well, because I don't want any other column to be generated, or I don't want this column to be removed. So then if I click on OK, then it will take some time, and okay, so now now that these are separated differently, like scientific name 1 and scientific name 2, these two have been separated using spaces. So as you can see, just like here, this one is together, and here these are separated. Alright, now there are many entries in our data type. We can filter it to work on a subset of the data in the list for the next set of operations. Now for that, we need to ensure that we perform these steps to save time right? So however, to filter the data, we can click on the scientific name, then go to the text filter. If I click on it, then the text filter has been created here. Case sensitive, you can have to write it down. Then here it is like a facet. Now if I click on by, okay, and so it is showing me that there is almost 48 matching rows that has by here in the scientific name. So that starts with by. Okay, fine. Now what you can do, that if I click on 50 here, it will show me the 50 matching rows where the scientific name starts with BI. So this is how we can filter out the data using the text from the text. But you can just filter this data using the scientific name, how they start. If I want another something, it might be A, B, C, whatever you like, we can do that as well. Alright, now that we have separated the scientific names, or the data set for the scientific names that starts with by, now we can see the text facet for it. So let's go and check it. Okay, so this is the text facet here, which has been created. Now we can do that, we can include or exclude here. So you see that if when we drag our cursor over these two texts, we can see that include here. So if I want to, there is a Chatotipus Bailey, because Bay, it also starts with Bay, so it is also considering it, but we want to see only the items or only the samples that starts the first term of the scientific name starts with BI. So if you want to do that, then you have to click on include, so it will be excluded. Now it will be shown here. So if I want to see that one, we have to exclude it and then click on include here. So now it will only show me the samples where the first name or first scientific name starts with biomass or the bio. Alright, now let's see how we can sort the data. So here if you want to sort, then we can choose any column. So for the time being, let's click on this one, scientific name, and then here, what if I want to sort, then we can choose text, numbers, date, or whatsoever. It can be text, you can save, but sorting by the text, it doesn't make any sense because we have already sorted them out. We've already filtered the scientific names that starts with BI. So for this we can work on with month or year also, but since we have converted the year into the time format, but let's just work on with month now. So if I click on month, MO, then we can click on the sort, and here we can click on the smallest first, let's say the number, and then here you can see the smallest first, largest first are sorted by this column alone. Let's just for the time being click on the smallest first and then press OK. So then what will happen is this data set will be sorted by the month. You will see that 111, it means January, then February, March, April, May, whatsoever. This time the serial is not being maintained, rather it has been sorted with according to the month here. Now if we want to undo it, then all we can do is click on, then again go to month, then go to sort, and there is reverse and remove. If we want to reverse it, we can do it by using clicking on reverse. So what will happen is that the December will come first, so it is 12, December, November, October, September, and whatsoever. But if you want to remove the sort, we can also do it clicking on the remove sort. So it will be sorted, and then the OpenRefine will show the data as it was before the sorting. Okay, we have seen different kinds of faces, and now we have just discarded all the faces here, so it returns us the everything that was previously shown, that is more than 35,000 rows. The previous data, the actual data, now this time it is showing the 50 rows here. However, now let's just see the comparison or the correlation between two numeric columns. So for it, let's work on with record ID and period. To make for this to work, we need them to be in numeric values. So these are in text now, as you can see these are in black. To convert them into numeric, we have to do it is cells, then common transform, then to number. We'll perform the same thing with the period. We'll do data cell, common transform, and to number. So it has also been converted into numeric. Now if we want to see the scatter plot, then what we'll have to do is go to Facet, then scatter plot. Now it is showing us the record and the period, record ID and the period. We can see them in this way and this way. We can take log or len, whatever we like. So let's keep them there this way and select the log. We can also make the dots bolder or smaller, whichever you would prefer. You can do it your wish. So let's keep it because it makes it look more clearer. Okay, now while working on with OpenRefine, you might wonder, or you might need to go back to your previous setting or previous, like this time I have done we worked on with record ID and period. We made them numeric from text, but what if we require them to go to the previous step, like in the text? So OpenRefine got it covered. All you have to do to click on undo redo, and here you'll see that all whatever you did has been stored here. It's showing us that to number, or from creating project to every step. We can see here everything has been recorded. Now these are, whatever we do, are saved in as JavaScript object notation, or in short we can call it JSON. These are saved by default, and we can export this JSON script and apply it to other data file. Like the thing that we have done here, we can export the same thing, or the same, like it will work as a function to other data set as well. So to do that, we have to click on extract, and here you see that everything has been stored as JavaScript. We can click on export to export it. It has been, now you see that's saved here in the browser, history.json. Now there are other things that you can do, like now you have, if you want this data, that thing that we have done, we have brought a lot of changes here. We have separated scientific names, we have changed the year to date time format. We have also worked with record and period. Now what if we want to export the data? So to export the data, all you have to do is go at the top right corner and you'll see that export. So if you click on export, then you will find a lot of formats that you can use. You can format to Excel, you can if you have the latest one, you can use this one, or if an old version, then you need this one. You can also convert it to Google Sheets, then Wikibase, then HTML table as well, SQL exporter, template. But for the time being, let's keep it as OpenRefine project archive to file. So what we'll do is, it has created a OpenRefine.tar gz file. So it has been opened and it has been saved as in the computer as this format. Now you can use any other thing. So you can double click on it and find the exact directory where it has been saved. So for example, here it has been saved here in this download folder in my computer. Here there is a data, history, metadata, all JSON, everything that you have done, or every necessary items that you might require has been saved here. So this is how you can export the data. And if you go to the data carpentry link, you'll be able to see different ways you can save your data, save this your work, and mainly based on your own operating system. So the link will be given down below. However, I hope this video was enough and gave you a simple idea how to work on OpenRefine. And now you can choose any dataset that you have and play around. All you have to do, go to open, and then another OpenRefine window will open here, and then choose from the beginning. So that's it. This is how you work on OpenRefine. So I hope it was helpful, and thanks for watching.